Find the azimuth of course CD. In this problem, points A, B, C, and D form a closed traverse. A direct and inverted azimuth is measured from each point to its two adjacent points on the traverse, where the first direct azimuth value is approximately 0 degrees and the first inverted azimuth value is nearly 180 degrees. The direction of each course in the data table refers to a relative coordinate system and only used for the purposes of calculating the interior angles of each of the four vertices. However, the problem provides the true azimuth from point A to point B as 80 degrees, 28 minutes, 8 seconds. The problem asks to find the azimuth of course CD, which equals the azimuth of course CB plus angle BCD, where angle BCD can be calculated from the data in the data table, and the azimuth of course CB equals the azimuth of course BC minus 180 degrees. The azimuth of course BC equals the azimuth of course BA plus angle ABC, where angle ABC can be determined from the survey data, and the azimuth of course BA equals the azimuth of course AB plus 180 degrees. And the azimuth of course AB is given in the problem statement. The only unknown variables we need to solve for the azimuth of course CD is the measurement of angles BCD and ABC. Now we'll return to our survey data and balanced closed traverse in order to determine angles BCD and ABC. For angular measurements, balancing a closed traverse means that the sum of all interior angles equals 180 degrees times the quantity n minus 2, where n equals the number of vertices in the closed traverse. Since n equals 4, the sum of the interior angles should equal 360 degrees. Beginning with the first two measurements, courses AD and AB, the measurement of angle DAB will equal the azimuth of course AB minus the azimuth of course AD. Keep in mind, for these measurements, 0 degrees refers to the general direction of the first course measured. It is not necessarily aligned with true north. After plugging in these values, the calculated measure of angle DAB equals 94 degrees, 5 minutes, 0 seconds for the direct measurement, and 94 degrees, 5 minutes, 5 seconds for the inverted measurement. Since all measurements are made to the nearest 5 seconds, we'll round the average of these two angle measurements up to 94 degrees, 5 minutes, 5 seconds. Next, we'll move over to point B and use the survey data for courses BA and BC. Similar to angle DAB, angle ABC equals the azimuth of course BC minus the azimuth of course BA. After plugging in the appropriate values, angle ABC equals 80 degrees, 34 minutes, 35 seconds for both direct and inverted measurements, which will also be the calculated value for this angle. We'll determine angle BCD and angle CDA the same way, by extracting the measured azimuth values from the data table, then subtracting the azimuth of one course from the other for both direct and inverted measurements, and calculating and averaging the angle measurements. If we sum up the angle measurements for all four calculated interior angles of the closed traverse, we get 359 degrees, 55 minutes, 25 seconds. This will require an adjustment of 4 minutes, 35 seconds, so that the sum of the interior angles balances out to 360 degrees. We will balance each angle by adding 1 minute and 5 or 10 seconds to its existing value and come up with our final interior angle values. From earlier in the problem, we determined we needed to find angles ABC and BCD. Now we can solve for the true azimuth of course CD, because the true azimuth of course BA equals 260 degrees, 28 minutes, 8 seconds. The true azimuth of course BC equals 341 degrees, 3 minutes, 48 seconds. The true azimuth of course CB equals 161, 3 minutes, 48 seconds. And finally, the true azimuth of course CD equals 253 degrees, 53 minutes, 43 seconds. When reviewing the possible solutions, the answer is D.